All right, let's roll through this last quiz review of the course. Number 1, an exercise is conducted on a sample of 50 students. For the exercise, the mean is found to be 123.6 with a deviation of 9.2. If the same exercise is conducted on a group of 75 students, which statement is false? Well, which statement is false? Make sure you read these carefully. Which statement is false? The standard deviation is likely to change to 11.5. It is not likely to go up, because if your sample goes up from 50 to 75, your deviation should go down from 9.2 down to something, right? So it is not likely to change to 11.5 if you increase the sample size. One solution of a quadratic is known to be 2 minus 3i. What is the other solution? This is a review question. If you have 2 minus 3i, the other one must be 2 plus 3i. It's simply the conjugate. A bag contains a total of 90 chips. Some are red, the rest are blue. Student pulls a sample of 72, and 33 are red. So 33 out of 72 are red, and that is a 0.46, and that's your p hat. That's your p hat, 0.46. In the 3 scenarios below, one describes a survey, one's an experiment, and one's an observational study. Hopefully you read them over and tried these. The first one is the observational study, just observing what's going on there. The second one is the survey, because visitors were asked. And the third one is the experiment, dividing into 2 groups with a treatment variable. Okay? Page 2, we rolled through page 1 nice and quickly, right? Page 2. Stats class of 17 students wanted to estimate the proportion of all students in the school who liked the school lunch pizza. Each of the 17 students took a random sample of 30 students from the school and asked them, do you like the school lunch pizza? The following are 17 sample proportions. Sample proportions of students that said yes. So you're going to construct a dot plot here. I'm not going to do the dot plot for you. You guys already know how to do that. So space it out, and I'm just going to put must do. You all know how to do dot plots. Equal intervals, space them out. You can go however, I don't care how you space it out, as long as it's equal, and then dot it up. All right? Put the dots over there. Okay, so that's there. Make sure you hand this in. You do have this, or you will not get full credit. You'll lose automatically a point out of 3 if you don't have it. Find the mean and standard deviation of these sample proportions. That's just from your calculator. So X bar, and if you don't have a calculator, you couldn't do it. So again, this is from 1 var stats, right? Just list 1. Just list 1 if you put them all in list 1. X bar comes out to be 0.58, and then SX is 0.10, and again, that is from 1 var stats. If these 17 students were to now collect data from random samples of 20, what effect would this have on the mean and standard deviation? Well, it was random samples of 30. Now we're going down to random samples of 20. The X bar is expected to be about the same. So we would X bar, we'll just put X bar about the same. The X bar, the mean, doesn't really change too much. It can go up or down. Somewhere around 0.58 probably, though. And the SX, the standard deviation, will actually increase. So you're going to have a worse standard deviation, a bigger spread, because we have a smaller sample. We decrease the sample size, so we increase the standard deviation. A set, I don't know why this keeps popping down on me. A set of data that's normally distributed has a mean of 127 and a standard deviation of 12. Find the z-score for each. Remember z-score. You take the value, subtract the mean, 127, and divide by the standard deviation, which is 12. So your z-score for 141 is going to be 1.167. And then for 99, same thing. Your z-score for 99 is going to be negative 2.333. 3. All right, so using your table normal curve areas, which you have in your notes, you could find the probability that a piece of data is at least 132. Now remember, when you're using that table, you draw a picture, okay? At least 132. Well, here's the mean of 127, okay? 132 is above that somewhere, and I want to be at least. At least is 132 or more. So that's what I'm talking about right there. 132 or more, at least 132. When you look at your table, the number that you look up the z-score for, that is, so you would have to do a z-score for 132 actually. So let's do that first. 132 minus 127, I didn't give you a lot of room here, divided by 12. That z-score is 0.42, 0.42. So look up z equals 0.42, look that up in your table and do 1 minus it, because when you look it up in your table, that's going to give you all this area to the left of the 132. We want the area to the right of the 132, the probability at least, the probability greater than. So the answer is 0.33, final answer is 0.3372. Now on your calculator, you could do normal CDF and go 0.42, the z-score, to 9999999, and then 0.1. 0.1 for your mean and deviation if you use the z-score. Okay? Using a calculator, find the probability it falls between 123 and 135. So what we're going to do on our calculator, I know you don't have it, so just write down the keystrokes here. The normal CDF, we're going to go 123 to 135, and then the standard deviation, the mean of 127, and then the standard deviation of 12. You would just type that in, list them out, 1, 2, boop, 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 right? Lower, upper, mu, and then sigma. Lower, upper, mu, sigma. Boom, 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 boom. You paste it, it looks like this, and you're going to get 0.378. Okay? All right, a health group study recommends that the total weight of a male student's backpack should not be more than 15% of his body weight. For example, if a student weighs 170 pounds, his backpack should not weigh more than 25.5 pounds, because that's 15% of 170. Do 25.5 divided by 170, it's 15%. Suppose that 10 randomly selected 11th grade boys produced the following data. So here's their body weight. These are all their body weights. It's what they weigh, okay? And this is their backpack weight for each student, okay? And then I did this for you, percentage of body weight. So if a kid weighing 155 pounds carries a 29.8 pound backpack, that's 19.2% of their body weight. A boy that's 136 pounds carries a 27.2 pound backpack. That's 20% of his body weight. 20% of his body weight. All right, and that's over the recommended amount. Most of these are over the recommended amount, right? Just this one's under. Based on the percentage of body weight in the table, estimate the mean percentage of body weight that 11th grade boys carry in their backpack. Well, the estimate of the population comes from the average of the sample. Remember, increasing the sample size or saying, the population is not going to change the mean that much. As long as you have a good amount of sample proportions, in this case sample percentages, as long as you have a good amount, it's the average of your sample can be, we're going to say that's about the average of the population. So if they ask you to estimate the population, you're just going to take the average of your sample. So again, average all these percentages up. So add these up and divide by 10. There's 10 of them. All right, add those up and divide by 10. So plus, 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 divide by 10. And the X bar comes out to be 18.12%. So the average percent that the boys in our sample were carrying on their back was 18.12% of their body weight. Not the weight, percent of their body weight. The average percent of their body weight is 18.12%. Now, In your calculator, one var stats would have done that for you, right? And the sample deviation came out to be 2.2. So again, I did this for you. This can come from one var stats as well as this, 2.2. Of the percentage of body weight, you get your one var stats. Now I got to do the margin of error. Okay, so margin of error is 2 times the sample deviation divided by the square root of the sample size. So S over the square root of n. And that is 1.391. So again, the formula is 2 times S over the square root of n. This is a sample mean. Even though they're percents, we took the average of the percents. So we did sample means. And this is the standard deviation percentage. That goes there. See? So S goes on top and the square root of n goes on the bottom. N is the sample size. That was 10. 1.391 is our margin of error. All right? Comment on the amount of weight 11th grade boys are carrying. Let's comment on that. Well, if you get your interval, let's do an interval first. So let's do 18.12 plus the margin of error. And let's do 18.12 minus the margin of error. So even if we subtract the margin of error, we're still at, it comes out to be 16.729. It's 16.729 to the high end of 19.511%. This is percentage of body weight. So even on the low end of our interval, remember the interval is 95% confident. We're very confident that the average percent of body weight is in that interval, 16.7 to 19.5. It's very likely that they are over the recommended percentage, which was 15%. So that's what we're going to say. It is very likely that the average percent of body weight 11th grade boys are carrying is well above the recommended %. Okay? It's very likely the average percent of 11th graders, of all 11th graders at that school, that the average percent is well above the recommended 15%, because even on the low end of using our margin of error, the low end of our interval is 16.7. So we could go even further than the margin of error, say it's even more likely than 95% that the boys are carrying a high amount, average amount that's above the recommended limit. All right, so two of the more popular places in Western New York for chicken wings are Duff's and the Anchor Bar. You may or may not know that. We have Duff's in Niagara Falls. We don't have Anchor Bar, but that is, you may have heard of the Anchor Bar. It's a popular place in Buffalo for wings. A student went to the Galleria Mall, which is centrally located, and there's Anchor Bar and Duff's around that area, and asked 175 randomly selected people which place they prefer. Now, if you did this study in Niagara Falls, it's probably not a good study because we have a Duff's and we don't have an Anchor Bar, so a lot of people may not have done both. Centrally located where you can get good answers like the Galleria Mall, it's a good place to ask. 175 were asked, right? 119 of them said they prefer Duff's for wings. So 119 out of 175, that comes out to be 0.68. That's going to be our p hat. So our p hat is 0.68. That's the proportion that preferred Duff's over anchor bar. All right, compute the margin of error. Well, for margin of error now, we have to use our sample proportion margin of error, and that's 2 times the square root of p hat times 1 minus p hat. So it's 0.68 times 1 minus p hat, which is 0.32. Again, that's 1 minus p hat, 1 minus 0.68, divided by n, which was our sample size of 175. All right? And that comes out to be 0.071. So our margin of error is 0.071. Determine an interval that would contain 95% of the sample proportions and explain what it means. All right, so let's get our interval. 0.68 plus 0.071, 0.68 minus 0.071. And that's going to be 0.751, and that's going to be 0.609. All right, it is very likely, in fact, 95% likely, it is very likely that between 61 and 75%, okay, it is very likely that between 61% and 75% of Western New Yorkers prefer Duff's to the anchor bar. Should say wings. Duff's wings to anchor bar wings. Okay? It is very likely that between 61% and 75% of Western New Yorkers prefer Duff's wings to anchor bar wings. We're not going to say it's 68%. That was just our sample, right? But margin of error based on our sample size is only 7%. So go 7% above and 7% below. 0.071 is 7%. All right, so within 7% of 68, so from 61 to 75, in that percentage, we can tell that it's very likely that somewhere in there is the percentage of people that prefer Duff's to anchor bar. All right. Last one, Gallup Organization, right? We did Gallup polls before, right? There's a problem with this one, and I don't know if you noticed it, if you read it over. It talks about age 18 to 29, then it says adults 18 and over. So let's see, sample of adults. We're going to say 18 and older here, just so it's consistent for our sample size, or else the problem really doesn't make sense. I think there was an issue here with the way they wrote this problem. Anyways, we're going to just get into the answer so I don't keep it too much longer here. So the margin of error, we're doing its proportions, right? So we got a p hat. Our p hat is 0.58 because that's 58%, right? 58% cell phones or smartphones. So it's going to be 2 times p hat times 1 minus p hat. This time it's 0.42. And then again, our sample size is 1,051. So 1,051 adults. All right, and that comes out to be, oh, darn, I didn't do that. Real quick, sorry. 2 times the square root of 0.58 times 0.42 divided by 1051 is 0.030. 0.03, let's say. Okay, so 0.03 is our margin of error. And how do your results compare with the margin of error stated in the article? Well, they said maximum margin of error plus minus 5 percentage points. This is a 3% margin of error. See that? 0.03, 3% margin of error. So how do our results compare with that margin of error? They compare very good. They compare very well. So this is under the max margin of error stated. So it is consistent because it says max. It doesn't say it had to be 5. It says max 5. So it is under that. Interpret the statement: the margin of sampling errors plus minus 3 percentage points. It is very likely. It is very likely that the population proportion is within 3 percentage points of the sample proportion p hat. Okay? It's very likely that the population proportion is within 3 percentage points of the sample proportion p hat, which was 0.58. So 0.03 above, 0.03 below. So 0.55 to 0.61. Let's put that. 0.55 to 0.61. All right? Put that in parentheses. Just more information, the better, right? What would happen if Gallup surveyed 100 people instead of 1,051 that they did? What would happen to the margin of error? Well, again, as you increase the sample size, you decrease the margin of error. So here we are decreasing the sample size. Therefore, we are going to increase the margin of error. So margin of error will increase due to smaller sample size. All done. I will see you for the quiz.